Hello everyone. In this video, we will discuss how we can solve the definite integrals by using the concept of numerical integration. So we usually use the method of numerical integration to solve a definite integral when we have like very complicated integrals or the for the integrals whose integration cannot be obtained by using the direct formulas. So, given the integral a to b fx dx, when we are solving it by numerical integration, we use different techniques. Maybe it's trapezoidal rule, Simpson's rule. In Simpsons, we have one-third rule or three-eighth rule, and many more. Okay, so what we usually do, this integral a to b, a is the lower limit, b is the upper limit of the function f of x. So this is the graph of your function f of x. Your interval of integration is from a to b. So what we do in numerical integration is we divide this entire interval into sub-intervals, starting with say first interval as x0, this say x1, x2, x3 and so on, indicating the last point as xn, which is same as b. Okay, then what we do, we add up the area of these small rectangles. That gives you the value of numerical integration. So let's now see how we can solve a question with the help of trapezoidal rule. Suppose you have this integral. Okay, you have to solve it by using the trapezoidal rule with n subinterval. Here the important thing is that when we are dividing it into subintervals, width of each interval is same. So if this is h, this is also h. So how do we find it? H is given by the width of entire interval, that is b minus a, upper limit minus lower limit, divided by n. N means the number of subintervals. It means in which interval, in how many subintervals are we going to divide the interval AB. So let's say this. So comparing this with the previous one, so we know that this is your A, this is B always. And what you have the function here? The function is this. Okay, let's write down these things. Given that the subintervals are 6. So let's write down these things. So we have A is equal to 0, B equal pi by 2, N is equal to 6, and your function fx, which we also write it as y over 2 plus 3 sine x. So note that it is everything except this dx. Okay? So everything what is the integrand, that function you are integrating is fx. Now the first thing that you have to do is to find the width of each subinterval. We have to divide it into n subintervals, so we should know what is the width of each subinterval. So it is given by the formula b minus a over n. So what is your b? B is pi by 2 minus a is 0 over 6. When you simplify this, you'll get pi over 12. I recommend to keep it as pi over 12 instead of making it into decimal. Okay, because if you make it into decimal, uh, you will not be able to reach to the final value. Let's see how you will work on it. So it is pi over 2. Okay, so let's begin with this. So you have h is equal to pi by 12. So suggested to keep it in this form because when you if you divide it, you are getting the value 0.2617999, means you are not getting a proper decimal. So it's like it's a non-terminating decimal. Okay, so in this case, what happen is like you will not be able to reach to the end. So I recommend not to use this. Okay, so now what is the next step? We have to divide it into subintervals. So we should know like, okay, if we are starting from 0 here, this is pi by 2. So what is this value of x1, x2, x3? So how we find it? we have this 0, initial point 0. H is pi by 12. So this distance will be pi by 12. Similarly, this is pi by 12. Then H is again pi by 12. So what you get? Pi by 12 plus pi by 12. That gives you 2 pi by 12. So let's work on it. So we will put it in the form of a table. So we get 0, pi by 12, 2 pi by 12, 3 pi by 12, and so on. We reach to 6 pi by 12. How do we know that where we have to stop? So if you see this value, 6 pi by 12, what is it? If you calculate, this is pi by 2. So you always start from the lower limit, 0, and you stop at pi by 2, the upper limit. Okay? It's up to you. You can also write it as pi by 6, but if you keep it in this form, that doesn't matter. You may write it as pi by 4, pi by 3. Okay? But don't convert into decimal. Because see, if you assume that you have used it as 0.2617, the decimal form of it, you will not be able to reach to pi by 2. Okay? So that's the reason I'm saying not to use this. Okay. Now, what is next? You need the value of the function, your function at all these points. So we noticed here, what is our function? Fx is 2 over 3 plus sine x. So let me write this function here. Fx is 2 over 3 plus sine x. So when x is 0, what happened to this function? At x equal to 0, it will become 2 over 3 plus sine of 0. So when you solve it, what you get? 2 over 3. So which is same as, up to you. Either you keep, now in this values, it's fine. You can keep like 2 by 3 or you can use the decimal. It's fine. So you will see that it is 0.66666. So you round it off to 0.6667. Better to take up 4 decimal places. It will give you the more accurate result. Now, let's see what happened when x is pi by 12. Just replace x here. So what we are actually doing, we are replacing this x. We replaced it by 0. Now we are going to replace it by pi by 12. So f of pi by 12 is 2 over 3 plus 3 plus sine of pi by 12. Now, when you are measuring this angle, make sure you are keeping the calculator on radians mode. Okay. So, when you calculate it, you will get the value as 0.6137. Okay. So, you write this value here, 0.6137. So in the same way, what you have to do, like what we did, when we replace x by 0, we replace just this value of x. When we replace x by pi by 12, we replace just this 2 divide 3 plus sine. These things remain same. You just change the angle. Same thing you have to do for pi by 6, pi by 4, pi by 3, 5 pi by 12, and 6 pi by 12 or pi by 2. So when you do all this thing, what values you will get? Let me fill the table. Similarly, when you have here 0.5173, 0.5042, and here 0.5. Okay? Okay. Once it is done, what you have to do is you have to use the trapezoidal rule. So this is the general formula for the trapezoidal rule. It says that integral a to b fx dx is given by h over 2 plus the sum of the values at y0 plus yn plus 2 times the sum of values at the inner points. So now, first of all, modify this rule for your question. What you have here, your n is 6. So it means you replace here n by 6 and here n minus 1 means 5. So when you modify the formula, what you will get for your integral, it is h over 2 y0 plus y6 plus 2 times y1 plus y2, y3, y4 and y5. Okay. What is important to note here is this bracket. This bracket, it means that the value h by 2 is multiplied after solving all these terms. Okay. So now, what are these y0, y1, y2 and so on y6? So your function is nothing but y. We are denoting it by y. So as I said, we are calling these points are x0, x1, x2 and so on. Same way we are calling these points, the correspective y values as y0, y1, y2, y3, y4, y5 and y6. Remember, always start with 0 and as you need 6 in subintervals, so you should end at y6. If they say 4 subintervals, you should end at y8. Okay? Sorry, if it is 4, you will stop at 4. If it is 6, you will 6. If 8, 8 and so on. Another important thing to note that here all the values comes only one time. Y0 appear only one time. Y1, Y2, Y3 and similarly all other values appear only one time. None of the value is repeated. Now what you have to do? You have to just substitute the values here to get your integral. Now what is h? H is pi over 12. So substitute here. So this integral gives you pi over 12, this whole divided by 2. Then better to put a bracket. Okay. Then sum of first and end. So it is 0.6667 plus 0.5. To check if you like, make sure that you are not using any value again. So just make tick once you are picking the value. Okay. Plus 2 times y1, which is 0.6137. Okay, done. Then y2, 0.5714. Okay, done. Then 0.5395. In this way, what happened? You can find out if you are making a mistake by using a value repeatedly. Okay, you can avoid that mistake. So 0 point like this and then close the bracket. Now, just simplify this by using calculator and you will get your answer. See that you have to do it carefully. First, multiply all these terms, add all these terms, multiply with 2, that gives you this term, add the first and last term, okay? Then multiply 2 with this term, okay, in this way, add them, and then divide by, multiply by 5. So this is the value of your integral. Okay, so this is how you work with the trapezoidal rule. Let's assume that if the same question is asked to solve by using the Simpsons rule, okay, they just use the rule. Then what happens? All the procedure will be same except the rule, okay. So what do I mean is you have to find fx, your fx will be same, you have to find your width first. Find the width in the same way because a and b doesn't change. Okay, your function is this. Then up to preparing this table, everything remains same. What will change is just the use of rule. So you will be using this rule instead of the previous rule. So how does this rule differs? Here, first of all, it is h over 3. It's because this is Simpson's 1/3 rule. Okay. There is Simpson's 3/8 rule also that we will see later on in another video. Okay. So here h over 3. Okay. Then what you have? Y0 plus yn. Yn will be y6 because you have 6 interval. Then what you see? 2 times y2, y4. So what do you think the next point will be? It continues. y6, y8. So it means all these are even points. Okay. Whereas 4 times the odd points. Y1, y3, next will be y5, y7 if that exists in the table. So it's odd. Okay. So now let's see what this rule take the form with your values. So we have this table. Here we have y0, y1, y2, y3, y4, y5 and y6. So again in this rule also all the values should be used only once. None of the values should be repeated. So in our case it becomes h over 3. Okay, the rule says y0 plus yn. N is 6. So y0 plus y6 plus. So it means y0 gone, y6 gone. Then 2 times the even points. So if you start with even points, what you have? Y2, okay, fine, plus you have y4, okay, and then you have y6, but y6 is already used, so you are not going to use it here again. So it contains only 2 points, okay, clear? Plus 4 times odd points, okay, y1, y3, and y5, okay, 1, 3, 5. And then we stop and close the bracket. Again, first simplify this bracket and then multiply by h over 3. Okay. So you can also check like how many points you are having here. 1, 2, 3, 4, 5, 6, 7. And in your table again 1, 2, 3, 4, 5, 6, 7. So you covered all the points and none of the point is repeated. Now what left is just substituting the values. H is 5 by 12 divided by 3. So this you can use by calculator. Okay. Y0 plus Y6. 0.6667 plus Y6 which is zero point 0.5. 2 times even. Even is Y2 which is 0.5714. Okay. And 0.5173. 4 times odd. 0.6137, 0.5395 and 0.502. So when you are working, how you will work? Find the sum of all this, multiply by 4. Sum of these two, multiply by 2 and add these two. Okay, then add all three of them, then multiply by 5 over 12. So when you simplify, you will add all these numbers, multiply by 4, add these two numbers, multiply by 2, then add all this. So this gives you this sum and then get your answer. So you'll see that this rule is giving you more accurate answer. Okay. So this is what you got 0.8716 by trapezoidal rule and this is what you got by the Simpsons rule. So if you check with the accurate value by using exact value by using your calculator, you'll find that this is something 0.8704. So Simpson's one-third rule gives you the more accurate value. Okay. So I hope it is clear how do you solve an integral by using the numerical methods, trapezoidal rule and the Simpson's rule.